All right, so our last two examples, instead of just giving us numbers or drawing Venn diagrams, they've given us what we call two-way tables. And just like the title right here, a two-way table, a table that records data and pertains to two different categories. That just goes in that notes right there. Now, there is one thing that would probably be very helpful to do before you even look at any of the problem. Notice that they gave you the number of juniors that went to prom. So these are juniors that said yes, they went to prom. These are juniors that did not go to prom. It would be probably helpful to know how many total juniors you have. So I would total all of these things right here. So if I add my juniors together, I've got 28 plus 56. There's 84 juniors that they talked to. And seniors, there's 97 plus 19. So there's 116 seniors. So total number of people, we can even add those together. Total number of people that they polled for this lovely little table was 200. Okay, we could also count the number of people who, yes, went to prom. If we add that 28 plus 97, we get 125 people that went to prom. I bet you can guess that 75 did not, but let's go ahead and add 56 plus 19. And yes, it's 75 because these numbers also have to add to our 200. Okay. Now we've got all these totaled right here. It's going to be pretty fun and easy to find our probabilities. Now, again, this lesson we're talking about conditional probability. That's when you see these lines right here, that means that they're giving you a condition. But notice on this first example, this first example did not give us a condition. There's no condition there. So you were just trying to find out the probability that if you grab one of those people at random, that you pull out a junior that did not attend prom. Okay, so again, no conditions there. So your total number of people that you could choose from is 200. So that's going to go on the bottom right there. All right, now your favorable outcomes, the number on top, you're looking for juniors, but more specifically, not all these juniors. You're looking at juniors that did not attend prom. So it's got to be in the junior column and say no to prom. Okay, so there's 56 people right there that were juniors that did not attend prom. And then if you wanted to, you could simplify this. Let's see, they both divide by 4. So this is 13. No, yes, 13 over, sorry, hold on. Let me put the right numbers into my calculator. So 56 divided by 200, and then we're going to turn it into a fraction. So this is 7 over 25. So evidently they both divide by 8. So that would be a great answer. If you don't want to put it into decimal, you could, or to fraction, you could leave it as a decimal. It was 0.28 was your percentage when you just divided that. So that's the probability that you grab a person at junior, or grab a person at random and they're a junior that did not attend prom. Okay, this next one, we're now going back into our conditions. They gave us a condition. So you always look at the last thing. Okay, just remember the last thing goes on the bottom. We are only looking at seniors now. Okay, so we're just going to look, these are the only people we care about for this problem. So how many total seniors do we have? We have 116. We want to know what the probability is that I choose someone at random and they did not attend the prom, but it's given that they're a senior. So again, you're not looking at any of these juniors. Ignore those. We're only looking at these seniors. How many seniors did not attend prom? Well, how many seniors said no? There were 19 right here. So that'll just go on the top right there. And then you could try and simplify it. I don't think it does simplify. Let's just look. Nope. That's a good answer. You could leave it like that, or you could write it as a decimal, 0.164. Okay. All right, let's look at one more conditional probability. Again, they gave us a condition. So on the bottom, we're now looking at the people who attended prom, who said yes, they attended prom. So we're only looking at these numbers this time right here. Okay, so there were 125 people that juniors and seniors that went to prom. We want to know what the probability is. If I go to prom, if I just grab one of those people, what's the probability that they are a junior? A junior, and again, you're only looking at the juniors that went to prom because we know that we already know that that was our condition that they attended prom. So we have 28 here out of that 125. All right, and then again, I'm checking my calculator right here to see if I can simplify that. And you cannot simplify that, so that's fine, or you could write it as a decimal, 0.224. All right. Okay, this is the exact same problem. Let's look at this one next. So we're going to go ahead and add these together very first. So 16 plus 52, that's going to give me what? 68. 12 plus 60 is 72, and we've got 20. All right, then 16 plus 12 plus 2, that gives me 30. 52 plus, I'm going to grab a calculator for this one, 60 plus 18 gives me 130. So this adds up to 160. Let's make sure this does too. 68 plus 72 plus 20, 160. Good, so we think we did it right. All right, again, these first two probabilities, they are just basic. They're like last lesson. Okay, they are no conditions. We want to know what's the probability that you chose one person at random from these people. So again, there's 160 people, and that they happen to be a coach class traveler that did not check any bags. So they've got to be a coach class with 0 bags. There's 18 of them. Okay, we'll come back and simplify all the fractions in just a minute. Okay, second, what's the probability? Again, there's no conditions. See, there's no slash bars right there like this one. So no conditions, so we know that we're looking out of all 160 passengers. What's the probability that a first class passenger checked at least one bag? So they got to be first class. They can't check 2 bags, but they can check 1 bag, or they could check 2 bags. This is a little tricky one. They've got to check at least 1. So these people both checked at least 1. So we can add those together. 10 plus 10 is 20. 6 plus 2 is 8. So 28 right there. And these are fine answers. We'll come back and simplify them at the end. But if you want to leave them like that, that would be fine too. All right, now we've got a condition. See that nice lovely line? We have a condition for this one. We know our person checked 1 bag. We're only looking at these people who checked 1 bag. So the total number of people that checked 1 bag was 72. So I'm only looking out of those 72 people. How many of those 72 people were in coach class? All right, so we just look here. We say, oh, there's our 60 right there. 60 were in coach class right there. And that kind of, sorry, covered up all of my words right there. All right, now we're going to look at this next problem. Okay, now we know that our person is in first class. So we know that we're looking at just these people right here. So total first class passengers was 30. We want to know how many of those 30 first class passengers checked 2 bags. So just look up here at that 2 bags, and it's a 16. Okay, again, these 2 answers would be completely fine. They do simplify to 9 over 80 for this one, which 9 divided by 80 is 0.1125, so that would be fine too. 28 divided by 160, that simplifies to 7. They both divide by 4, so 7 over 40, which is also 0.175. Okay, either of those. 60 divided by 72. My calculator will simplify it, tell me that's really 5/6, which is also 0.833. It keeps going. And then 16 divided by 30, and that will simplify. If you divide them both by 2, you got 8 over 15. If you put it into the calculator, you got 0.533. All right, so any of those answers are fantastic. Hope this helped, and have fun with your probability homework.